Welcome back, everyone. We are excited now to move on to our next and final session, Changing Climate, the Potential and Limits of Technology for Sustainable Cities, organized by SRI graduate fellows Tanya Agrawal, Han Chao, Wenxi Liao, and Hu-Feng Chung. This session will be moderated by Tanya Agrawal, who's a PhD candidate at the Department of Computer Science, and Han Chao, who's a PhD candidate at the Faculty of Information.
Cool. So before the session actually starts, I'll just introduce our speakers and then say a few words for the motivation behind our session. So our group decided to involve every team member in the session facilitation process. So online, we have Wenxi, who is a PhD candidate in the Institute of Forestry and Conservation and Department of Civil and Mineral Engineering at the University of Toronto. And here in the room, we have Feng over there, who is a PhD student at the Faculty of Information. And I'll start off the session with a quick introduction to the session written by Feng and a brief introduction to our amazing speakers written by Wenxi. We also prepared a QR code for those of you who might not feel comfortable asking your questions in person. So feel free to scan this QR code and put your questions into the Slido whenever you want throughout the presentation. And we'll be collecting all the questions in the end. So one key motivation for us to have this session is that the threat of climate change has intensified concerns regarding how intricate urban, agricultural, health systems confront environmental challenges. As many of us are aware, environmental data plays a key role in approaching the complexity of climate issues. However, it is necessary not to overlook the process involved in producing, gathering, and using such data. This requires an interdisciplinary and cross-sectoral approach to understand the potential and politics of environmental data. Today, alongside our two speakers and moderator, we extend an invitation to all participants to reimagine the convergence of climate change, environmental data technology, and socio-ecological justice. And now I would like to invite our speakers one by one to come up to the front of the room with us. So today we have Dr. Reza Najafi. Reza is an associate professor in the Department of Civil and Environmental Engineering at Western University. He leads the Hydroclimate Extremes and Climate Change Lab, whose interdisciplinary research program focuses on addressing the challenges associated with non-stationary hydroclimatic extremes, particularly floods and droughts. His work contributes to the development of robust risk and resilience frameworks supporting the sustainability of both the natural and built environments. Reza currently serves as an associate editor of the AGU Water Resources Research Journal and as a co-founder and co-director of the Center for Multi-Hazard Research and Resilience at Western University. Let's welcome Reza. Next, we have Dr. Maaz Gardezi. Maaz is an assistant professor in the Department of Sociology at Virginia Tech. Maaz's group explores the interaction of climate change and the socio and political implications of emerging digital technologies in food and agricultural systems. His interdisciplinary work aims to build sustainable and socially just food and agricultural systems. Professor Gardezi led several projects through his Technology Environmental Society Lab at Virginia Tech with funding with the NSF, the United States Department of Agriculture, and National Institute of Food and Agriculture grant. He also works closely with different sectors, including the private sector, nonprofit, and as a consultant to various government bodies. Let's welcome Maaz. So our session today will consist of short talks from each speaker about their research, followed by a panel discussion with our speaker, after which we'll take questions from the audience. Without further ado, let's welcome Reza first to talk a little bit about his research.
Thank you. All right. Hi, everyone. I'm very glad to be among you, and thank you all. Thank you very much for the organizers of this session. So I'm going to talk about hydroclimate extremes, climate change, and resilience in general. As you're aware, we are kind of living in an era where things are changing quite fast, both in terms of the technology that we had interesting talks about today, AI and machine learning, and things are happening very fast in a matter of few years. But also the climate change that is affecting all of us, but the rate of change is quite sharp, that is somehow scary and raises the question of whether we are really, as human beings, able to adapt and respond to these changes. So kind of divide the talk, which is relatively short, into a discussion of extreme events, adaptation, and basically climate justice. So if you go back to 1954 in October, an event happened. There was a tropical storm that started affecting the Caribbean islands, like Haiti, and then moved northward, turned into a hurricane category 4, and affected states in the US. But in an unusual scenario, it continued towards Canada and past the Great Lakes, and dumped huge amount of rain over 48 hours, affecting the GTA area. And that was a very rare event, causing about 80 deaths, thousands of people were displaced, and lots of damages to the structure. That event is particularly important because it led to initiatives. It led to the creation of the conservation authorities, for example, and with their mandates. It led to the idea of floodplain mapping and risk assessment and these sort of things. Now, flash forward about 70 years, 2013. Now, there is another catastrophic flood affecting Toronto, this time due to a thunderstorm. And this flash flood causes road closures, subway shutdowns, power outages, among others. So the expectation might have been that maybe things have been better managed. We don't know. Have we developed measures good enough? And are these only the residuals of the risk? Or could we have done a better job? Now, the problem is that things are changing in a way that we see more of these events happening in recent years. 7 of the 10 most costly Canadian floods have occurred after 2010, which is quite alarming. And that raises the question of how will these events change in a future scenario? Now, there are 2 aspects of this problem. One aspect is related to the climate change and hazards and intensification of these hazards because of multiple factors associated with climate change. And the other factor is the exposure. We have more population, more infrastructure that are exposed to these hazards. And on top of that, we are learning more about hazards, and we are seeing that these hazards that traditionally we used to investigate them individually, focusing on risks associated with floods or wildfire or tornadoes, actually these hazards, they interact with each other and they amplify each other effects. For example, you may remember in 2021, British Columbia, they experienced a heat wave, severe heat wave in around July 2021. That triggered a wildfire, which was quite extensive. In November 2021, flooding happened. And how does flooding and heat wave and wildfire are related? Well, there have been instances where flooding after or extreme rain after wildfire can cause mud flows. And while in a situation where you have only extreme rainfall happening, well, you might have some flooding and the damages can be manageable. With the mud flow, things were completely different, and many people were killed because of that. There are other instances. For example, droughts generally coincide with heat waves. There are many, many examples in which we have multiple months or few years of drought conditions and multiple occurrences of heat waves that can add to the problem of water demand and health issues, right? What about floods and extreme wind? As you know, both are kind of coming from similar mechanisms in some situations like hurricanes. Even with floods, we have different types of floods, like coastal flooding, heavy rainfall, pluvial flooding, and river overflows. And during hurricanes, all of these collide and amplify each other's effects. So we are looking at all of these, and what we are noticing is that in a changing climate, not only these events individually are getting more frequent and more intensified with a sharp rate, but also their interconnection is getting stronger and stronger, which means that while previous decades ago, flooding and droughts could happen randomly, now we kind of see a trend that nations experience a kind of a multi-year intense drought period, and suddenly it's followed by flooding. And then again, it shifts to drought. Or there's wildfire, and then suddenly there's extreme rainfall. So these interconnections are also worrisome. Now, these are all on the hazard side. When we assess the risk to the communities, buildings, infrastructure, we also consider the assets and the exposure. Now, in the traditional assessment of the risk, we focus on the individual asset. If there is a property, we assess the flood depth and proximity of the property and whether the damage can occur. But in reality, when we're dealing with infrastructure, including urban infrastructure, when an asset fails, it can cause failure in other assets. When there's power outage, that can affect the water treatment plants. And if there is road closure, that can affect the access to hospitals. So there is a new kind of a paradigm shift towards risk assessment of infrastructure by considering the interdependencies, which are complex and can be tricky because of security issues and the need to access the data, etc. And by the end of the day, these hazards accumulated with all these consequences affect us as humans. Now, suppose that we have developed all these complex models and we have all the data, and you issue the warning right on time before an incident happens. The question is whether people or agencies will take action in a timely manner. So the expectation is yes, of course, there are emergency services, there are people who are educated, they will respond, but we have very, very recent cases like the 2021 European flood, that show that no, that doesn't work out quite well. In in Europe, they issued warning 1 week in advance. Actually, not one warning, it was 50 warnings that were issued. And still, that led to plus 200 plus deaths, right? So going from warning to action and how we communicate the messages, how we educate people to respond is a whole other issue. Now, at Western, in our lab, we focus on these hazards and how they interplay and how they change in time to address some of these problems that we currently face, because things are changing. And one of the major issues that we have is that these information that we use are quite uncertain. We rely on models and we rely on data that show different projections into the future. So how can we incorporate this uncertainty into our planning for the future? The research should definitely be multidisciplinary, because climate change, as you know, is affecting all of us. So engineers need to be involved for developing well-designed structures. We need collaboration with climate scientists, because we rely on their climate models and their projections to plan accordingly, because without climate change models, we don't have anything to rely on. We cannot rely on the past as we used to do. With social scientists, we need to connect to people and incorporate their knowledge and also mix it with the data and the modern knowledge. So these are all very important and require interdisciplinary approach. We also created this Center for Multi-Hazard Risk and Resilience, which the intention was to bring people within the academia. That's another problem, because in academia, we are working in our departments. If this is an engineering department, we do engineering work. There is not a lot of motivation to connect to people in other departments to do interdisciplinary research. So that was one of the motivations to do that. And of course, we rely on data, lots of data, and we process these data using different algorithms. This data can be observations like satellite, radar, and also simulations from climate models. So one example of these analyses is the so-called hydroclimate swings. That's one good example is what happened in California. In 2012 to 2016-17, California experienced a multi-year drought. And there were a lot of research, a lot of media coverage, and a lot of discussion about the drought in California. And right afterwards, in 2016-17, it turned into an extreme flooding. You might have heard about the Oroville Dam failure and the evacuation of thousands of people because of that. That was associated with that flood. And then examples like that started to occur quite often around the world, in China, Australia, and different places. So the question is, are we facing a new trend, a new pattern? So one way to look at them is through the lens of the climate change models, and there are a lot of advancement in these models. Typically, these models, there is uncertainty related to internal variability of the system, and also different models perform differently. So we tend to consider multiple models and have a sense of the overall response of the system to global warming. So we use a so-called large ensemble. We looked at variables like precipitation, soil moisture, runoff that are commonly important in terms of the drought and flood analysis. And we considered future periods corresponding to kind of a medium warming levels of 1.5, 2 degrees, global warming levels up to 3, 4 degrees. And well, through some definitions and statistical procedures, we defined what is the dry, basically, period defined as what about the wet period, and how we can do a kind of a multivariate analysis and characterize these transitions over North America. So interestingly, if you look at these graphs, the ones on the top show the frequency and the transition time on the bottom, and this is the transitions from dry periods to wet based on the precipitation, and this is wet to dry. And areas that show higher frequency with increases in warming levels, as you can see, are the ones that are reddish on the coastal and southern areas. The ones that are currently also facing these events, like California or Texas, etc. What about the transition time? Interestingly, we notice quite sharp signal in terms of the transition time, meaning that this time window that typically was long enough for us to respond and recover. If there is a drought, we can recover, there is normal situation, and suddenly flood happens. This time horizon, this time is decreasing with global warming. So this is best shown on this figure, where you can see the transition intensity is expected to increase, while the time in between these opposite extremes is decreasing. So this is one type of analysis of the interactions between different hazards. Now, on the other side, now there is a topic of mitigation and adaptation. We recently worked with the city of Toronto, and it was interesting that they wanted us to do a kind of a comprehensive review of global best practices for stormwater management. And we learned a lot from this project. So essentially, we looked at Toronto, city of Toronto, and 10 other cities globally, including Ottawa in Canada, a few cities in the US, New York, Boston, San Francisco, for example, in Europe, Copenhagen, London, Berlin, and also Melbourne in Australia. And we did a comprehensive review of their guidelines and all the literature that was available, as well as doing surveys and talking to people who are in the field. And first of all, we were impressed with the amount of activity and initiatives in relation to stormwater management capacity building in these cities. And secondly, we noticed that looks like they're taking the reasonable approach. How much it will be effective, we'll yet to see, but we can quantify that. But traditionally, flood management was in the lens of structural management, building dams, canals, right? If the water level goes beyond the canal's capacity, then it has failed. Everything has failed, right? But we have learned as humans that those systems do not work. They're not enough. So the current approach is to mix the nature-based solutions, the so-called LID, or low impact development, with the structure-based solutions. Essentially, we have no other choice as well, because let's see, we have all these sewer networks, all these pipes underground beneath us in the city. And we know that the intensity of rainfall is projected to increase. Can we replace all these pipes and make them larger? Maybe we can, but it will be drastically costly. And knowing that climate change is uncertain, well, how much larger can you build it? So the approach is basically, they name it different things: unified stormwater rule, sponge city, cloudburst management. But essentially, we are taking a centralized approach out and decentralize our management. Now, public and private sectors and people should work together. And the emphasis is to reduce the load to the stormwater system at the property level. Now, there are all sorts of policies and design factors now being involved. As one example, how do you incentivize people to implement green roofs? Can you enforce it? Right? One way is through the stormwater fees. So some cities, they charge stormwater fees for their management. All right? Now, by reducing the stormwater fees for properties that implement these nature-based solutions and reduce the load to the system, then you can encourage them to go ahead and take those solutions, right? And there are all sorts of ways to do that. So this was one example of how you can take newer approaches and evaluate what others are doing, bring the risk assessment frameworks and climate change into perspective, and plan for the future. Of course, urban infrastructure is just one aspect of the problem. What about mitigating flooding in rural areas? What about agricultural fields? And so on and so forth. And finally, I want to touch on the climate justice through one example, the city of New Orleans in Louisiana. So the Mississippi River Basin is a very large basin. About 40% of the area of U.S. Is covered by this river basin. And of course, so there are lots of economic and social activities there. Now, the river itself has a unique character in the sense that it's quite chaotic, it's meandering with lots of erosion and sedimentation. Now, if you look at the history of what the developments happen in this area, we notice that all the good measures that we learn in our water resources textbooks were being implemented in 1940s, 50s, 60s by U.S. Army Corps. Measures like constructing levees along the rivers, that currently we also take this approach, and we are proud of that as engineers. Or ship canals to facilitate the transportation. Why not doing that, right? Or getting rid of the marshlands and develop the lands for different purposes, residential, commercial purposes. Or building seawalls and dikes, etc., because the area is also susceptible to storm surge and hurricanes, etc. All right. But it turns out that all of these measures, one by one, led to the catastrophe that happened during Hurricane Katrina. Now, the issue is that people started talking about climate change, act of God, we have done our best, so on and so forth. But if we look deeply into this problem, we notice that most of the problems were associated with the way, the approach that was taken towards controlling the natural river system. For example, all the levees that were built, they basically, yes, they controlled flooding for specific areas close to that levee, but also it increased the discharge in the levee, which means that it increased the erosion. So that led to the reduction in sedimentation in the mouth of the river, which naturally, through natural process, will build lands. It eroded it and helped with seawater encroachment into the land. And people actually could see it, could see the water coming into their lands. The marshlands that existed for long, they were quite effective mitigation measures in terms of stormwater, in terms of storm surge control, right? Which were gone afterwards. The seawalls and levees that were constructed, they gave a false impression to people living in those areas that they are safe, even with the most catastrophic event, but they weren't, and it breached, and the low-lying areas were all flooded. And of course, where the levees were breached and which areas, for example, farmlands that belonged to poor people were flooded instead of areas that kind of belong to more valuable assets, rich people. So all of these are part of the discussion about climate justice. And we all have responsibility as researchers, engineers, social scientists, etc., practitioners, to know that the decisions we make, first of all, we can solve a problem, but that can cause other issues. But also, keeping climate justice in mind is very crucial, because fundamentally we can take design measures and planning that favor smaller groups, richer people, and negatively affecting the poor communities. All right, so my takeaways basically is that the cities and communities, they require adaptive infrastructure in light of climate change. And our current infrastructure, our current design are not capable of withstanding the hazard events that we are going to face in the near future. Analyzing past events is quite important, like Hurricane Hazel, Hurricane Katrina, to give us insight of what the region can expect. But as you're aware, things are happening that are unprecedented, like the flooding that occurred in Dubai. Nobody expected that. So we partly rely on the new data and technologies, satellite and radar data, which are growing quite fast, and also climate change model simulations that provide better and better insights into the future. But also we should incorporate the local knowledge and involve the communities in making decisions for the future. So to make sure that our approach is effective, definitely requires collaboration with people in different fields, and we have to break the barriers between different disciplines and learn our language, first of all, because our language is a barrier. A term resilience can have tens of meanings for different people. So understand each other, communicate to be able to address these problems. And of course, policy is the key. The act of voluntary work is of course important at individual level, but we require policies and regulations that promote being risk aware, reduce the risk, and also encourage the interdisciplinary collaboration and research. And with that, I'll leave it here. Thank you very much.
Thank you. Next, we'll have Maaz to introduce his research.
Hi, everyone. Okay. So I'm just going to quickly skip some of the slides. Reza's, your slides, I'm guessing. So thank you all for being here, and a special thanks to the graduate students as well as the Institute for inviting us and for arranging this. It's very nice as we're having these conversations around climate change, and I also want to acknowledge Reza as kind of helping set up the situation here so that it'll be easier for me to present then instead of explaining things again. So I do want to kind of acknowledge that some of the work that I'm going to present is a result of the hard work of a lot of grad students who work with me, as well as other collaborators. So this isn't entirely my own work. I'm kind of presenting other people's work, as well as like and as well as the communities that have partnered with us, who have given their precious time and energy to us. So I really, my research focuses on 2 different regions of the world. So I do a lot of work in Pakistan. I'm originally from Pakistan. And I do work with indigenous communities in the north of Pakistan, which basically is they're situated within some of the loftiest mountains in the world, including K2, which is the second highest mountain. It's only 2 hours away from these communities. And so I'm not going to discuss more about these communities today, but I'm going to talk a lot about my work in the US. And in the US, I do a lot of work in agriculture and food security and climate change issues. But I do want to just set this stage with a little short anecdote about some of the work that connects well to what Reza was saying, which is when I do work with my communities in Pakistan, these communities don't really have an early warning, early action system for flooding. But they're situated in the catchment area of River Indus, which is one of the largest rivers in the world, which is very prone to flooding. And during one of my recent trips, I asked them, hey, how do you figure out that you need to evacuate when a flood comes? And you know what their response was? Can anybody guess how they figure that out? Their response was that they hear these loud, echoing sounds coming from the mountains. It's the rivers that are hitting the mountains. And do you know how much time they have to evacuate once they start hearing the sounds? 2 hours. So in 2 hours, once they hear the sound, they have to evacuate. And my obvious question was what would happen if you either did not hear the sound because you were asleep? They were like, well, then we don't really have a system. So now this tells us 2 things, which again goes back to what Reza was saying. One is that you cannot rely on a top-down system of governance, which is mismanaged at many different levels, right? You cannot have a early warning, early hazard system that's controlled by the government, right? Because the government is never going to provide these indigenous communities with any kind of services that they need. Number 2, these communities have very strong relations to environment and nature, right? And is there a way in which we can build these systems, or is there a way in which we can understand governance by understanding their interconnection to nature, right? So all of the work that we do in our research, in our lab, is understanding the human relations to nature and using that as a guiding principle for developing, whether it's policy, whether it's governance, whether it's new innovation. So some of the innovation I'm going to talk about from our standpoint is new, but that's not the only source of data that's available to us. Communities have access to data, which we may not consider as data. We've talked about experiential knowledge, epistemic issues in today's discussion, but I think it's really important to acknowledge that these knowledge systems, epistemologist is sitting right here, these knowledge systems matter, right? And so I'm going to talk about in the US context, in a place that's totally foreign to me. I'm not from the US, I wasn't born here, I came here 12 years ago. So, and I'm going to be studying 3 different states in the US that are very different from one another. South Dakota, large-scale agriculture systems. 10,000, some of the farmers that I work with own 10,000 acres of land. Very conventional systems, growing corn, soybean, very, very Republican, right? Politically conservative, religiously conservative, fiscally conservative. And then Vermont, very hip. Permaculture, you talk about any kind of, you want to grow marijuana, they're the first ones to do it. Right, so all the cool things that you think can happen starts in Vermont. Bernie Sanders, right? So politically very, very, very democratic, right? And then Virginia, which has an interesting racial history, right? You wouldn't find race in any of these conversations that we have in South Dakota or in Vermont. And as soon as you move to Virginia, you interact with these very interesting farmers. But I also want to introduce myself. So I'm a sociologist, but I have an appointment in computer science and in plant science. So I'm nowhere, right? Which fits nicely with the theme of this workshop. And so one of the methods that we use, and I wouldn't call it's a method, it's more like a methodology, is the idea of the living labs, right? And so more recently, a lot of living labs have been established in cities. Right? How can we understand from different sources of sensing and sensors, and what can we learn from that for understanding human behavior or for developing policy. And so we've been focusing the same kind of things, but in agriculture settings, right? And so here's the paper that we just wrote. And you can see the list of all of these people are my collaborators. And so I'm leading a team of about 30 people. I have funding of about $4.5 million. So this is a huge project that we've been working with the National Science Foundation and the USDA. And so therefore, like, this cannot be done by one person. I've spent a couple of years just like talking to computer scientists and engineers and policymakers just to get a sense of how we can actually set this up. So this is what we have. We have about 30 living labs, so 30 farms in these 3 sites. And this is what we do with them. So what we're really trying to do at the end of this is to understand, like, what are some ways in which farmers, right, in general in the communities that they work in, can reduce the environment pollution that they generate. So what are the ways in which you can have less nitrogen, less phosphorus, and less carbon? Anytime a farmer, like, just to like sort of give a background to non-agriculture folks, like when farmer adds fertilizer on the soil, some of that nitrogen seeps into the ground and turns into nitrates as it flows into the water. Nitrates kill fish. Nitrate leads to hypoxia. Oxygen goes down. It destroys the environment. Some of that nitrogen also goes up into the atmosphere as nitrous oxide, which is 30 times more hazardous than other like carbon dioxide as a greenhouse gas. So agriculture is a huge contributor to both water quality and greenhouse gas emissions. And one of the things that we're trying to do is, like, what can we learn from these farms, and what are some ways in which we can develop these technologies, whether there are decision support tools or AI-driven decision support tools that we can help to reduce some of these impacts. So a lot of our time is kind of building relationships and situating these relationships based on ideas of trust. So we started out with 30 farmers, and we still, after 4 years, are still working with those 30 farmers. Zero attrition. And the reason for that is because they learn and participate in the project as much as they want, and we get to, like, they get to understand a lot of the things that we are developing with them. So for instance, our team is involved with doing soil testing, flying drones, producing satellite imagery. And then what we do with this is that we, out of those 30 farms, we kind of divide them into these 4 groups, okay? And a little bit of sort of empirical analysis over here, but I'm just gonna make it very simple. So some of the farms that are part of this project, each farm basically is divided into four fields. So on some farms, we basically give them a basic process-based model. A process-based model is basically simulates the physical processes that exist in the environment. You can give it some input, it processes and presents some output. So just to give you an example, something like, hey, how much yield would I get if I put this many pounds of phosphorus? So you can input phosphorus amount and it's gonna output yield, right? So that's a basic phosphorus-based, like process-based model that USDA or other agencies have developed. For other farmers, we give them a better information model. So this is the one that has some AI wrapper around it or is more enhanced as a result of presenting not only the processes, but also uncertainties with it. That this is how much phosphorus, this is how much yield, but these are the sensitivities, these are the uncertainties around it. For some farmers, we give them some basic monetary incentive, right? Just for thank you for participating, and that's it. And for other farmers, we are paying them based on how much pollution they can reduce. So based on exactly how much pollution they can reduce, we can actually give you an incentive. So we are testing 2 things. Does information make a difference? And number 2, does money matter? Okay? And it's very simple, but in the real world, it can be very challenging because all of these are real farmers. These are not experimental sites. These are farmers that are totally autonomous. They can do whatever they want. They can decide to withdraw from the experiment. They can and so we're trying to test like what would happen in the world if we have to go like that. So each farm is divided into these plots. And then we go to the farmer and we say, this is the information that we collect from you. But a lot of this cannot be done in the real world, so we can also simulate it in the form of a video game. And this video game basically is also played by the farmers. And in this situation, we're asking what would happen if they had to make a choice between a crop advisor, like a human crop advisor, an artificial intelligence, or whether they go for a computer app. And so the farmer would go in, we would present them some information, and then we'll say, based on your choice, the agent that you choose recommended this much fertilizer. Would you go for this, or do you go for more? So, and they kind of receive actual payments based on the outputs of the video games. Some of the things that we can tweak from those video games are, we can make this process more stochastic. We can give them different levels of uncertainty about their different choices. But the interesting thing is that you can also simulate time periods. So just as farmers make decisions based on their previous year's decisions, you can see what would happen as you, based on your last year choices, what would happen next year, and you can play it in iteratively. We do a lot of design workshops, and one of the things we want to achieve in these design workshops is the development of an app that can be used by themselves as well as their communities. But this is sort of a typical thing that most computer science, like scientists would be interested in doing. But we can also, like this is the app that we're developing that can give them kind of real-time information about the data there, and so each farmer gets their own version of the app. They can enter, and then they can get access to all that information. But then we can do something more speculative. So here's New Farm Times, a newspaper that we created, just to get a sense of what would happen in the future. So here's an example of small-scale Vermont farmers reduces phosphorus use by 20%. So you are the farmer, what is it that you would do? Here's another speculative prototype that we use to kind of have more engaging conversations with them. And these are some kind of design images that we use to understand a little bit in a speculative sense about the alternative futures that they would want. So some of the things that you can do with these images, in our case, what we do is we ask them to kind of rank their preferences in a Q-sort manner. Here's another activity that we've kind of developed for a science museum exhibit where you can choose your adventure, but in the form of based on the choices that you take, and you end up in some scenario. And we're hoping to kind of use it both for collecting data, but also there's going to be a kids version of it that can be for a science museum of a younger population. I just want to stop here and thanks. I think I was given that time frame. Thank you. We'll have a more engaging discussion as well. Thanks. Yeah. Okay.
Hello, everyone. I just heard myself really loudly. I'm Tanya, and I will be moderating the second part of the session today. But what a great series of talks, guys. I thought that both talks did a wonderful job of what we understand of climate and technology today. So why don't we just give a round of applause to the speakers once again, show our appreciation for their presentations. I noticed a bit of a lag there. How's everyone doing? Like energy-wise? I know it's been a long day. We've sat through some difficult conversations, AI and military. What was that? Problems in online content moderation. But now we're going to talk about happy things, like climate change. No, seriously. So do you know that scientists reached a consensus on global warming in the 1950s? Basically, they had this one table which showed that as the concentration of carbon increased in the atmosphere, the temperature increased. And now we're talking about these sophisticated, complicated climate mitigation, climate adaptation strategies, how to use AI, how to help farmers in Pakistan and other parts of the world. So this is progress, right? We have come from that one single table to understanding how climate actually is changing, how we adapt to a changed climate, how we mitigate it, and all those fun things. So now, I'm going to dive into the next section of this workshop, which is the panel discussion. And to kick us off, I'd like to throw a few prompts for both of you. So please feel free to respond in the order that you wish to. But just to kind of get the audience reacquainted with your individual research areas, what does a research agenda that focuses on addressing climate and environmental challenges look like? Like what kind of people, what kind of organizations, what kind of institutions does this include? And also what kind of issues do you deal with in your research?
So I imagine many, many years ago, when we didn't have these modern instruments to measure, like rainfall, and at those times, people could communicate it verbally, right? And if they wanted to build a structure, they had an idea from their parents and their parents how the flooding, droughts, and other events would happen in that region. In modern times, we have collected data, and we rely on the data. We develop statistical approaches. We process that data. We come up with some exceedance probabilities and do the design. And it has its own challenges. We are always faced with the limited data and uncertain data and those sort of urbanization. But that did the trick. We had the data, we could do the analysis and come up with a deterministic type of design factor and design our bridge, culvert, dam, and communities, etc. But under climate change, the problem is that we are facing with a future that we are unaware of. We don't know that future. Yes, we do have these models that provide some insight into the future. First of all, they are climate models, so they give a sense of the climate in the future. They're not really forecast models. Secondly, they are quite uncertain. If you take, we have more than 20 climate centers around the world, about 40 plus climate change models. And while in the past few decades and recent years, there have been a lot of advancements in this. Still, if you look at the different model projections, especially with variables that are quite important to us, like rainfall, they give divergent results. Either one shows increases, the other shows decreases. So there's this range of uncertainty. And we have to make decisions. We have to design a structure that will last for 50 years, 70 years into the future based on that uncertain projection. So that is something that is, of course, my interest, how to quantify these uncertainties and how to communicate that uncertainty. And the other aspect is that, as I mentioned, looking at hazards holistically instead of focusing on an individual event, because these are the events that can cause larger effects. When there is extensive drought, and as a dam operator, your job would be to control all the water that you receive. So during this drought, if the rainfall happens, you will close the gate and hold all the water. If there is a flood warning, what's the decision? Are you going to release the water and keep the water level in the reservoir low so that you have more capacity? But what if the forecasts are wrong, and they are occasionally wrong? What will happen? You will lose all this precious water, and people will criticize you because in the summertime you won't have any water storage. And what if you keep the water? What if you release the water? In both cases, stakes are high. So that is my interest, to see these events as interrelated and making decisions accordingly, and then that helps us to assess the risks of our interconnected systems and eventually make plans and decisions that maybe not perfect, but more reasonable, more logical than what we used to do in the past.
Yeah, I just want to add that maybe I should just talk with my head down. So anyway, it doesn't matter. There's, like, I think there are two kind of big themes that are emerging in research when it comes to new technologies and specifically around climate change or sustainability in general. And it might apply to other sectors as well. One is the kind of the governance of technology. So technological governance would include questions like, we had panels around maybe questions of how do you moderate content online? That's a technological governance question. Maybe there's another question about ownership and access and privacy. Those are technological governance questions, right? And those are important questions. And the other one is is kind of the governing through technology, which is kind of which leads to other issues of algorithmic governmentality and like biopolitics. The idea that you can actually tweak people's behavior based on data, right? Or how you present them information and so on. And I think both of those are kind of real research agendas in agriculture as well. So when it comes to climate change, for instance, policymakers, we work with state governments. State government of Vermont is one of our clients when I say partners. And one of the things we do for them is develop these models that will eventually be used to kind of change farmers' behavior, right? As I described just earlier. And the challenge with those kind of models is that they don't tend to explain to the farmer, why. Why is it that the model is presenting those results? So one of the things that can be really useful at this stage for researchers that are thinking about doing research in this area is to either work on the development of models that are either explainable or more trustworthy, but on the other hand, kind of thinking through how do you engage with people? How do you engage with communities so that you can start thinking about ways in which these models could be trusted? And if not trusted, what are some ways in which those communities can generate resistance against these models? Is there a way in which the community can actually be brought together? And so community engagement can be done at both levels, building trust in models, but also finding ways in which communities are open to resist. And I think those are the two areas in general I would like more and more researchers to be excited about.
Yeah, thank you, Maaz. I think that segues into my next question for you specifically, but Reza, feel free to jump in if you want. You spoke to us a little bit about responsible AI for climate change. And I was wondering if you can speak to us a little bit about what that concept is, which parts of, all the research areas that you just expanded upon, does it touch upon? And also any interdisciplinary opportunities or challenges that you see within this area specifically.
Absolutely. So when I first got into the responsible innovation research area, I think at that time we did not have a lot of people from humanities come into this research area. So for instance, more recently we've been having discussions from feminist science and technology studies that are kind of shifting the ways that we think about responsibility in general. So originally, responsible innovation requires 4 key principles, right? Anticipation, so that you can think about the future impacts of technologies and innovation. Inclusion, that who are you including? Are you including the usual or the unusual suspects too? Third is responsiveness, like you have to be able to create systems of governance and policy that can help recreate the good things that you generate, right? And then the fourth one is like, how do you basically learn and continue to adapt based on what you're learning, right? So that's still very, very engineering mindset. And so one of the things that is, and no offense to engineers, I work with engineers all the time. I think one of the things that has changed is through what I say, the idea of the feminist STS, which brings in that you can think about responsibility in terms of responsibility, right? That all of us have the ability to be responsible. Some of us have more abilities than other people, right? But that doesn't mean that we're not responsible. And so by that, which ties in nicely with this idea that we're kind of all implicated in this. What ability do you have to kind of bring that change is not a question of whether you can or cannot. Is that you have some ability to do it. And I think this is really important in the case of climate change and agriculture, is because we're dealing with not only human relations, but non-human relations as well. We're dealing with things that don't usually come to matter as much. And we come to decide what things matter and what not when we make these AI models, right? So all of those decisions are human decisions in the end. And the question is like, so I'm thinking very philosophically about responsible innovation, but I think originally I was thinking very linearly, that if we can achieve these principles, we might get to a situation that's more responsible. One final thing I want to say on that is, when you're working with my dear colleagues in engineering and computer science, and it's very difficult to communicate to them what responsibility is. So in our case, it took us 2 years just to have a common understanding of what responsible innovation it should be, right? And then we realized that it's not just us, that we also have to work with the communities, like we have to understand what responsibility means to them. And then we were like, oh, it's not just about communities. What about the natural environment? How do we understand what's included in the natural environment? Right? And so like it's a pretty long, complex process. It takes a lot of years, many negotiated, heated discussions, but I think it leads to something that's really powerful. We're not there yet. Sorry.
Yeah, I think that's an important point. What does responsibility mean for different people? So Reza, as the engineer in the room, would you like to respond to that, or? Okay. So again, your research specifically deals with flood risk, and flooding is Canada's most frequent and most expensive disaster or climate-related event. So could you tell us a little bit about the flood hazard itself and what we should anticipate in terms of flood risks within climate change? Also, what does resilience mean in the face of these extreme events?
All right. Well, we all look at flooding in terms of one single event, but actually flooding can be driven with different factors, right? The main factor is, of course, extreme rainfall that leads to flooding. And we are all familiar with river overflows and riverine type of flooding. But there are several other types of flooding, right? For example, coastal flooding, in terms of storm surges and tides and sea level rise, or in terms of basement flooding. Actually, basement flooding is quite common in Canada, and that could be simply because of sewer backup, or it can be related to groundwater, increases in groundwater level. So there are different types of floods. So that means that each type has different mechanisms. So when you increase the global temperature, it's like people use this analogy, it's like a sponge. We have a sponge, is our atmosphere, it sucks the water as humidity, and it holds it in the atmosphere. And when the conditions are right, then it dumps the water, it squeezes the sponge, and we have rain, right? What is climate change? It's basically a larger sponge. The higher the temperature, the larger that sponge is. And we have a physical explanation for that as well. It's the so-called Clausius-Clapeyron relationship, which basically means that if you increase the air temperature by 1 degree, it holds 7% more water. Absolutely. And so we increase the global temperature, it holds more water, so if the conditions are right, then we have more fuel and it dumps all the water in terms of extreme rainfall. So one aspect of future expected flooding potential is that some areas, especially in Canada, are going to face more extreme rainfall just because of this process. And we are affected by jet streams, and extratropical cyclones, and all of these, they depend on the moisture in the atmosphere. The other aspect is things that more directly relate to the temperature, like snow. Canada in particular is affected by snow melt type of flooding, or when rainfall occurs on top of the snow and it causes rain on the snow. So how do these processes will change? Well, as expected, we will have, well, these are all uncertain, right? So I shouldn't use the word will, but we expect to have less amount of snow in many areas in Canada, depending on the warming level. So there is less amount of snow, so the kind of the flooding that is associated with snow can reduce, or also it can shift towards earlier times because snow melt happens earlier. In coastal, there's a lot of talk about sea level rise. When we talk about climate change, the people point to sea level rise, partly because of the glacier melts, Arctic, etc. And well, that's of course one factor, but also there are studies that show increases in temperature can increase the sea surface temperature. Increases in sea surface temperature can lead to more intense hurricanes and eventually higher storm surges. So coastal areas are kind of susceptible to these increases in water level. So in the future climate, how would flooding look like? Basically in line with what we are seeing. The expectation is that we are kind of at the 1.2 degree level above the pre-industrial level in terms of global warming. The expectation is that by 1.5, 2 degrees, we kind of experience what we are seeing, but at a more severe, more intense rate. But if you go beyond that, then who knows? You know, the catastrophes might happen. So this is in terms of flood hazard. Now, resilience is an interesting concept because traditionally how we approach flooding was through the engineering structural point of view to control flooding and to pass it away outside the area of concern. If this is a city, control it, build a canal, and let it pass as soon as possible. But the current approach to flood management is to basically hold the water and absorb it, use it to recharge the groundwater. But also in the resilience point of view. So resilience is different from our traditional point of view in the sense that traditionally we build a structure, if it fails, we're done, we are flooded. But the resilience point of view is that no, we are going through stages. One stage is the preparation and planning. Now we develop floodplain maps. We have an idea if this flooding happens, these areas will get flooding to this extent. So we have an idea of that and we can plan accordingly. So preparation and planning, lots of planning. Then, of course, absorbing the shock, you know, but allowing the system to, sometimes it's safe to fail. Sorry. And finally, this is the recovery stage, and there are a lot of programs and initiatives to strengthen that recovery. So resilience is kind of the package to approach flooding so that we can absorb it and bounce back quickly so that people can go back to their day-to-day lives. Of course, this is quite challenging, especially with these very severe events that we face, but through time, I think that has promise for the future.
Yeah, that was very helpful in understanding what flood as a hazard and resilience looks like. But I'm sure like the computer scientists in the room and the policy people in the room are wondering like, what can we do to kind of help build this resilience? Like how can we work individually or with each other or with other engineers to kind of help build this resilience in the face of hazards like flooding?
Yeah. So one of the interesting discussions in recent years is that what is the easiest and simplest way, the most cost-effective way to reduce the risk of flooding? And the answer is just don't approach areas that are flood-prone. Programs like Room for the River, right? When you develop floodplain maps, and this is one of the most important initiatives that some countries have already completed that. In Canada, this is a new thing in terms of Canada-wide floodplain mapping. But mapping the flooding and then deciding where to do the construction so that you're not exposed to flooding, that's one easy way to reduce the risk. Now, how AI and machine learning can help with that? They can help with it greatly because the models that are currently being used and developed, they are relatively computationally intensive. And we have numerous data sets available from past and projections into the future. So bringing AI tools and mixing them with our physical process-based models, then we can have more efficient models to help us develop these floodplain maps at a larger scale. And also high resolution enough that people hopefully at the property level can rely on. And in terms of other policies, so floodplain mapping and and land use planning, flood zoning, these are very important initiatives. One problem associated with that is, communities' structures are already developed, they're built, and perhaps they're in the flood risk zones. And you cannot just simply take people out of their homes and displace them. So how to deal with that? The flood events, and in general hazard events, when they occur, they generally create some momentum that help us at least overcome some of these challenges associated with taking people out of the hazard zone. The idea of building back better. So traditionally, when an area is flooded, a house is damaged or destroyed, then government provides some funding and they build at the same location, the same material, and if that event happens again, then we have the same story. But there are initiatives to help those people to move to other locations that are not at risk anymore. So I think this is a really good policy. Or other policies that incentivize flood mitigation measures. And that is where, for example, insurance industry plays an important role. When you are basically providing flood insurance, which is relatively new in Canada in terms of overland flooding, you can use that to leverage it and to, by providing discounts, encourage people to take mitigation measures at the property level, So, and stormwater management incentives, these was some of the examples that I mentioned. So policies are very important, both in terms of course, mitigation is something we didn't talk about much in terms of reducing CO2 emissions, but also in terms of adaptation and mitigation. Policies is definitely important. And the role of AI and machine learning is quite critical because we as engineers, water engineers, we have an understanding of these tools, but not in depth, not in detail. So that's where I think the expertise from computer scientists and also statisticians can help us develop models that are robust and meet the expected scope. That's one big challenge, which is we have our models, and sometimes we don't know what should be the expectation from those models. So we either heavily rely on them or we don't trust them, and in both cases, that can cause this issue.
Yeah, thank you for those examples. I wanted to ask Maaz to respond to some of that. Like Reza outlined some useful policies in terms of flood risk adaptation. And in your own experience working with like 3 different states and 3 different governments and political agendas, how do you, like broadly in helping create these policies and strategies, how do you, in your work, or how have you seen people engage the members of the public, and why is it so important?
Absolutely. And so I would probably give an example from Pakistan first, because that was more of a surprise to me as well. We went with, thinking that we could maybe do something similar as we were doing in the US, where like each individual farmer in the indigenous community would have access to their own individual information about how they can make agricultural decisions. And what we realized is that property rights did not exist over there. So people could not make individual decisions. Like that would not work. If you provide information to people on their cell phones, that just wouldn't make sense. So we said, okay, let's start thinking about what we can do at the community level, right? So I think it all starts by understanding who is the community, right? And a lot of times we can spend a lot of time just spending, like getting to know how things work. How is land owned? Who owns it? Who doesn't have access to resources and who does? And kind of starting from that point and building up, right? Instead of just randomly testing new policies and see how they would work. But then on the other hand, there are some tools that have been given to us from engineering, and especially like, industrial engineering, like that can be used to simulate what would happen if certain policies were actually to be implemented. So instead of actually trying out policies in the real world, you can actually simulate the impacts of policies by generating different agents and giving them specific rules. And so we can do, different types of simulation as well. So we do agent-based models as well, just to understand how policy could change. And then you could do something. What we did is like we can actually implement what the government would eventually implement, but in a small scale, on a smaller scale, on real farms, and then see what would happen. And then we can generate insights by giving some farmers better information and others some money, and by collecting data just as the governments would do in the future. So kind of taking a step further and seeing, hey, is this even worth it? And what we're finding is, and these are good lessons for all the state governments we work with, is that it may not work. The problem is that what is the alternative? So for instance, for the last 100 years, the US government has been paying farmers for practice. That if you implement this management practice, we'll give you this many dollars per acre. And we've seen that that hasn't really worked. So the government is saying, can we incentivize them by, instead of paying them for practice, we give them payments for performance. So like based on how much actual pollution you can reduce, we can actually pay you for that reduction in pollution instead of the practice. You can implement whatever you want as long as you can reduce the pollution. That's what the new policy is. So we tested it out, and we're finding farmers aren't sure where are the models, who's collecting all the data. They don't trust the government. They trust us because we're like putting sensors in their soil and giving them all that information. But the government's not going to do that. The government's just going to give them a check or a bill that will say, hey, you owe us this much, right? And so like working with engineers and taking them on the field, right? Like, hey, these are the people that will be impacted as a result of the models that you're developing in your lab. And these are actual people. And I think that's been a really good engagement exercise for us, has worked for the engineers that work with us as well. Thank you.
Great answer. So I think what has become evident with this discussion is that climate change is more than just a problem of global warming or data and like crunching numbers. It's a very intricate tapestry of things that affect people in a very real, personal way. And there are many more questions that I have, but I could sit here forever. So let's open it up for Q&A from the audience. We'll take a question from the in-person attendees first, and then, yes.
looks like it turned green. So that sounds like maybe it works. Okay, so my question is about technology and optimism, because people get very worried about climate change, and sometimes that can just shut down attempts to do anything because people just get despondent. And there's historical precedents for how technology changes our level of optimism. I'm thinking here of the 1968 book, The Population Bomb, the Ehrlich book, that claimed that basically we were going to have too many people, not be able to feed them all, and that turned out to be wrong because population growth began to decline, and because we became more efficient at feeding people. On the other hand, so there's an example of like excessive pessimism that technology outran. On the other hand, I worry today about a certain sort of technology optimism, people like Elon Musk, who are just convinced that we're not too far away from being able to make the human species interplanetary. And so we don't really have to worry too much about what happens to this planet because we'll eventually be putting people on all kinds of other planets. And there are lots of obvious reasons why that might not be the best strategy. And so anyway, so this is my question for you all is like what do we do? What's the balance between optimism and pessimism when we're using technology to confront a planetary problem?
So I think I'm not gonna give you the answer. Sorry, I'll be like a politician. But because I think I don't know what the answer is. I think what's happening and probably Reza, I don't know if you agree with me or not, but we're seeing that there's a lot of almost weaponization happening as a result of the ecological crisis that is being created around climate change. That, hey, climate change is going to happen, it's going to destroy everything, so hey, we need infrastructure. So or we need more AI. Without really thinking about why, or asking questions, okay, so what would happen? This is not going to solve. We saw the same thing happen with dams as well. Large dams, we need to store water, we need large dams, and look what has happened. Now people are finding it difficult to decommission dams, right? And so we get on these technological pathways and dependencies, and there's literally very difficult to reverse these things. So it's very important at this stage, I think, to stop and ask why. Why do we really need another AI thingy? It's more like a thingy, right? I don't know, Reza, how would you?
So what they say is that climate change is not a scientific issue, it's a political issue in terms of climate change mitigation. And that I think there are a lot of optimism around climate change. First of all, with climate change, we are seeing advances that I think have been unprecedented in terms of developments in science, in climate change models, in terms of communication between different disciplines, and our understanding of the system that we're living in, the Earth, the land, atmosphere, ocean system. Now, we are living in an era that we look back thousands of years and we do studies of paleoclimatology studies, and we have an idea how many years back it was a glacial period, what happened during that period, and what basically animals were affected, etc. So we have an idea of the CO2 concentration and what happened because of that, and so on and so forth. And it turns out that all of these fluctuations, glacial, interglacial periods, they all correspond to the changes in the CO2 that naturally happen within thousands of years. Now the problem here is that it's happening within tens of years. Okay, so interestingly, we have models that are getting better and better, and when they run these simulations over those past periods, they can represent them, they can mimic them with a reasonable accuracy, and that gives us hope that these are models that provide insight into the future. Now, there are some events that, if happen, things can go out of control. Like, what if all the Arctic glaciers melt? We'll have tens of meters of sea level rise. Okay, but now we know that this is far beyond happening, right? And we are closely monitoring other processes like Gulf Stream, etc. And so we have an understanding of how things can change. Our current policies are not enough, absolutely, but those kind of lead us to a 2.5 degree global warming level, which is still good. if they continue, and hopefully they get better. And we have had a lot of advancements in terms of coming up with effective measures, mitigation, adaptation measures. Now, if you look at the statistics, and we have the data, yes, if you look at the damage curves from insurance industry, you'll see that it's sharply increasing. All the cost associated damages are increasing, both because of more of these events and also exposure. But on the other hand, at least in some developed nations, the loss of lives is decreasing. And I think that's the most critical part. There are, of course, challenges, how we bring this equity into play, how we support other nations deal with this, because with climate change, some of these adaptation measures are really expensive. And it also requires education, new knowledge. So how to support them. But again, the science is there. It's just a matter of implementing them and communication. So I think it's important to highlight that there are these concerns, but I think there's good evidence that we're not approaching a doomsday, right? It's completely manageable. It's just in the matter of willingness of especially the policymakers.
Sorry, could we take one online question from the online audience?
So we have 2 questions online. I feel bad of not speaking it out loud, but feel free to pick one. So the first question is, what are some of the examples of local knowledges you can leverage for climate change, and how do you translate that into quantifiable data, or if quantitative analysis is even proper in the scenario? And the second one is, it's great to hear of the potentials of these technologies in helping to predict and tackle climate and environmental challenges. But what's often glossed over are the impacts that these technologies, including AI, are having on climate change. Think about huge energy footprints of data centers, etc. What are we doing to tackle these, and how do we begin to capture these impacts in our discussion and solutions?
They're both very important questions. Reza, do you have a preference?
So I think the first question more applies to Maaz, but I have some good example from where I come from Iran. And our ancestors, basically, they built canals. And these are interesting structures because they lived in dry lands and they needed water. And they knew that if they built canals and let the water flow with interaction with atmosphere, it will lose the quality, it will get warmer. So it's not quite suitable for drinking. So they designed these underground kind of networks. They dig the canals or pipes. They're not really pipes, but holes, horizontal holes with a very mild slope. And they were connected to the aquifers in the upstream. And they kind of directed the water to the villages downstream. And some of those, they were smart enough that they also had these roofs that they had openings, and when the wind would, there was windy, then it will circulate in the house and then reach the kind of the pond that was created because of that canal. And that will kind of provide a cool air in the house. I think that was brilliant. And recently, by recently I mean 10 years or more before, they built a similar system in a region in Africa, of course with modern machinery, and implemented this idea, which is kind of a green approach, to bring this local knowledge to address some of the issues.
Mm-hmm. Yeah, so in terms of the local knowledge question, very quickly, there are traditionally, statisticians social scientists have done a good job using Bayesian inference. We had a presentation in the morning as well, where healthcare AI systems in healthcare we're using expert knowledge and bringing them into computational social science research. And what that allows you to do is it basically reduces the uncertainty, right? So you have fewer errors because you bring in prior knowledge that you already have about so all of that is great. However, I feel like there's like in agriculture, people, like especially cultural anthropologists, have for several decades have been writing about the importance of local knowledge, indigenous knowledge, and we're seeing that happen again and again. I mean, I think even in our projects, it's very difficult to integrate those two things because in many ways, like AI requires very certain types of data. What I mean by that is that the soil tests that you do at universities, for instance, only measure certain parameters for soil fertility. And when you speak to farmers, they have a different understanding of what soil health means. They might be looking at the texture, and that isn't something that really comes up in the soil test results that then eventually that you can use to train the AI model. So in many ways, it's not necessary to blend Western knowledge with indigenous knowledge. I think those are two different like epistemological ways of understanding the worlds and should be kept separate. But I think what shouldn't be kept on the side is nobody has the right to choose which one is more superior than others. So I think that's kind of the only distinction I would make for that, the local knowledge question.
So we're slightly over time, so we won't be taking any more questions. But thank you to our speakers once again for a great panel discussion and a great round of talks again. And thank you to the audience for being with us while we did this.
So a huge thank you to all of our speakers, moderators, and to the graduate fellows who organized this workshop, filled with such fantastic conversation. This marks the end of our day and of our workshop, Interdisciplinary Dialogues on AI. And I hope you found the day as engaging and interesting as I did. We saw amazing discussions about the challenges and opportunities of AI in a variety of contexts, and we saw the urgent need for society-wide normative dialogue. We will continue the conversation tomorrow during the Absolutely Interdisciplinary Conference, which includes Gillian Hadfield in conversation with Peter Vailton on how AI agents interact with humans, a talk by Roger Gross on algorithms for AI safety, and Anna Su in conversation with Glenn Cohen and Huili Chen on designing human-machine coexistence. If you're interested, you can find more information about tomorrow's conference at absolutelyinterdisciplinary.com. And if you haven't already registered, we have an exclusive promo code for anyone joining us in person today, which can be used to redeem a complimentary ticket to both days of the conference. So just scan the QR code on display on the digital screens. Use the promo code and register, or let us know if you'd like help with that. So we look forward to seeing you tomorrow.